In this video, we're going to do an application that's going to involve three variables, and so we're going to be solving a linear system in three variables in this application. Okay, so let's go ahead and read the application. So we have a short-term bond that pays 4% annually, intermediate-term bond that pays 8% annually, and then long-term, which pays 10% annually. An investor wishes to earn $5,000 annually, and they want to have twice as much invested in long-term compared to short-term, and equal amounts invested in short-term and intermediate term. How much should they invest in each type of bond? Okay, so the three unknowns are the amount that you invest in each type. Okay, so let's go ahead and define that. X is going to be the amount, or I'll just write a dollar sign. So the amount of money invested in, we'll go ahead and start with short term, and then we'll make Y intermediate term, so dollars invested in intermediate term, and then lastly Z is the amount of dollars invested in long term. Okay. Alright, so now let's go ahead and set up our equations. Well, we know that he or she, the investor, wants to earn $5,000 a year. Okay, so how much is he going to earn in the short-term bond? Well, it earns 4% interest, so 0.04 times X would be the amount that he earns in the short-term bond. And then if we were to add that to the amount that he earns in the intermediate term bond, which is 0.08 times Y, and the amount that he earns in the long-term bond, which is 10%. And if we were to add all this together, we want that to equal $5,000. So we want him to earn, or we want the investor to earn $5,000 every year. Okay, next thing, we want to invest twice as much. So it says here, we want to invest twice as much in long term compared to short term. Alright, so the amount that you have invested in long term, which is Z, should be 2 times the amount that you invest in short term, 2 times X. And then also we have equal amounts invested in short term and intermediate term. Okay, so equal amounts in short term and intermediate term. So X then equals Y. This is my system of linear equations. Alright, first thing I'm going to do is I'm going to write this a little more like we're used to seeing systems of linear equations. Like I'm going to line everything up. To do that, and another thing I'm going to do is I'm going to get rid of the decimals by multiplying everything on the first equation by 100. Okay, you don't have to do that, but I just think maybe it's a little easier to deal with when you do that. So I'm going to go ahead and do that. So 0.04 times 100 is 4x plus 8y plus 10z, and then I need to add 2 zeros onto my 5,000. Okay, so that would be 500,000. Okay, and then on the second equation, I want to move this over to the other side. So I'm going to have minus 2x from both sides. I'm going to line that up over here. So this is minus 2x plus z equals 0. Okay, and then on the last one, I'm going to bring this over by minusing y to both sides. So I'll have x minus y equals 0. Okay, so let's go ahead and take this to the next slide so we can start trying to get this into upper triangular form and solving. Okay, so now I've rewritten the system of equations, and you might notice that I've changed the order of equation 2 and 3. And why did I do that? Well, I'm trying to get it into triangular form, and I want to have z in the last equation. Ultimately, I want only z in the last equation. So this equation didn't involve z, so that's why I went ahead and flipped them. And it's fine to do that. You're allowed to change the order of your equations to meet your needs. Okay, so let's see. So I'm trying to get this into upper triangular form, and the first thing I'm going to do is take this 4x that I see here and just make it x as a leading term. Okay, so to do that, I'll divide everything by 4. All right, so let's go ahead and write that. So instead of 4x, it'll be x, and then instead of 8y, it'll be 2y. That's 8 divided by 4. And then 10 divided by 4 is same thing as 5 divided by 2, z. And then that's going to equal 125,000. Okay, so let's label this. This is our new equation 1. This is equation 2. So the next thing that I want to do is I want to take equation 2 and I want to get rid of the x, right? In equation 2 I want to have y as a leading term. So to do that, there's two ways. I could take equation 2 and I subtract off equation 1. That would do the trick. That would get the x's gone. Another way I could do it is I could do 2 times equation 2 and add on equation 3. Okay? It doesn't matter which way you want to do it. Either will get you the same answer in the end of the day. So I'm going to take 2 times equation 2 and add on equation 3. I made that choice because I think it looks a little easier, but like I said, it really doesn't matter which one you go for. You can double check that yourself. You can do it the other way and see that you get the same answer. So first thing I'm going to do is 2 times equation 2, so 2x minus 2y, okay? So 2x minus 2y, and then 2 times 0 is 0. Should really leave space for a z there, okay. Alright, and then I'm going to write equation 3 underneath. So negative 2x plus z equals 0. I didn't change anything about equation 3, I'm just adding it on. Okay, so these cancel, and I'm left with negative 2y plus z equals 0. Okay, I need to have that leading term y to have a coefficient of 1. Right now it's a coefficient of negative 2, so I need to fix that. To fix that, I'm going to divide everything by negative 2. So then I'll have y minus 1/2 z. 0 divided by negative 2 is just 0. Okay, that's my new equation 2. So let's go ahead and write that up top. Y minus, let me write it underneath the previous y. So y minus 1/2 z equals 0. Okay, this is my new equation 2. Alright, lastly I need to deal with my equation 3. So here's equation 3. I need to get rid of the 2x that's out front. So to do that, I'm going to go ahead, I'm going to take equation 1 this time. So I'm going to take this equation 1 that's over here. You should always kind of work with whatever your current stage of the equation is. So I'm going to work with this equation. And so I'll take that one, and so what will I do? I'll have equation 3. And then, so equation 3 has negative 2x, right? Negative 2x. So this one has a positive 1. So I'm going to go ahead and take that. I'm going to add on 2 times equation 1. That should do the trick. If I do 2, then I'll have a 2 out front here, and I'll cancel with this one. Okay, so let's go ahead and write equation 3. Negative 2x plus z equals 0. And then let's do 2 times equation 1, and I'm looking over here at this equation 1 right here. So that'll be 2x plus 4y plus 5z, etc. So let's do that. 2x plus 4y plus 5z. Let's see, 125,000 times 2 is 20. Let's see, 25,000. 250,000, I meant to say 250,000. Alright, and let's add these together. These will cancel, and you'll have 4y plus 6z equals 250,000. Alright, now I need to get rid of the y. Remember, right now I'm trying to get this third equation to only have z, so I need to get rid of this y. So to do that, I'm going to take equation 2, and I'll multiply it by -4, and that should cancel. Okay, so let me go ahead. I'll just do this right underneath this right here. So I'm just going to do it right here. I'm going to do -4 times this. So -4y plus 2z, and then 0 times -4 is 0. Okay, so -4y plus 2z equals 0. Now these cancel. I'm left with 8z equals 2,500,000. Alright, so lastly, I need to get the z completely by itself. So I need to divide both sides by 8 to find what z is. So z is 250,000 divided by 8, which is 31250. So 31,250. Okay, so let's go ahead and write that up top here. This is our new equation 3. So z equals 31250. Alright, so now I have, this is upper triangular form here. Okay, so once I have the system in upper triangular form, I can back substitute to find all the variables. So let's do that now. Okay, so I have the answer for z. Z equals 31250. So what's y going to be? So we use equation 2 for that. I go ahead and I plug in 3125, okay, and that equals 0. So if I add this, or well, let me go ahead and do this. So that would be 15,625. Okay, so y then would equal 15,625, 15,625. All right. Now I know x equals y, so I could just say, okay, so x equals this as well. Remember, because that basically is what the second equation is, the x equals y. But I'll go ahead and I'll go ahead and look at equation 1 and do that as well, just to double check. So I should have 2 times 15,625 plus 5 halves times z. Okay. This equals, I ran out of room, so 125,000. Right, so I'm looking at this equation here, and I just plugged in everything. Okay, if I were to solve for x, I would have this equals plus x plus 31250, and then 5 halves, that's 78125. Okay, and that equals 125,000. Okay, so if I were to add these two together, that's x plus 10937, okay, equals 125. All right, so if I were to subtract 109,375 from 125,000. If I subtract those two, you get 15,625, right? So good, x does equal y, so that just verifies that all of our equations were right and everything. Okay, so now I just need to write my conclusion. Okay, so this is a word problem, so I need to make sure I've answered the question at the end of the day. So how much do I need to invest in each type of bond? So we're going to say invest 15,625 in X, which was short term, in short, and Y, right? X and Y are the same thing. So in short and intermediate term bonds, and 300 and or sorry, not 300, but 31,250, right? That's what Z is, in long term. Okay, and then I'm done.